I am Radhakrishna, mathematics teacher. Our today's topic is definite integration, lecture number 6. We are going to continue our problem solving on properties of definite integrals and inequalities in definite integrals, and also we have also discussed one method in which we can find out the definite integral by using differentiation. And this question is integral 0 to pi by 2 log 1 plus x sin square theta by sin square theta, where x is a parameter independent of theta. Earlier in previous class we have solved one question, if you remember. Integral 0 to 1 x power alpha minus 1 by log x dx. How did we solve? We took this definite integral as a function of alpha, I of alpha, and differentiating it with respect to alpha we got I dash alpha, then by integrating we got I of alpha. So we are going to follow the same approach in this question. Since we are integrating with respect to theta, after integrating, if you substitute the limits of theta, finally x will be remaining in the definite integration. So let us take this as a function I of x. Let I of x be equal to integral 0 to pi by 2 log 1 plus x sin square theta by sin square theta. Now what will you do? Differentiating with respect to x, I dash x is equal to, here this integration is with respect to theta, but x is independent parameter. So we will keep the definite integral and terms of theta same, we will differentiate with respect to x only. So we will write integral as it is, then differentiate. Derivative of log t is 1 by t, so we will get 1 by 1 plus x sin square theta into derivative of x sin 1 plus x sin square theta with respect to x will be derivative of 1 is 0, derivative of x sin square theta with respect to x is sin square theta. So into sin square theta, and denominator remains as it is, sin square theta d theta. Now what happens? Sin square theta cancels. Now how to find this integral now? It is in the standard form, integral of 1 by a square plus sin square theta, a square plus b square sin square theta. How to integrate it? We have a standard method, we have to multiply and divide by secant square theta. Integral 0 to pi by 2, multiplying and dividing by secant square theta, denominator becomes secant square theta plus x into sin square theta into secant square theta is tan square theta. And what is our idea? Since secant square theta is the derivative of tan theta, we are going to substitute tan theta is equal to t. So we have to write denominator in terms of tan theta completely. Integral 0 to pi by 2 secant square theta d theta by, write secant square theta as 1 plus tan square theta, then it becomes 1 plus, remaining becomes 1 plus x into tan square theta. Now substitute tan theta is equal to t. Then differentiating tan theta, we get secant square theta into d theta is equal to dt. Then this becomes, what are the new limits? If theta is 0, t is tan 0, 0. If x is pi by 2, tan pi by 2 is not defined, but we have to take limiting value. When x tends to pi by 2 from left side, tan theta tends to infinity. So upper limit is infinity. 0 to infinity dt by 1 plus x into t square. Okay, I will write integral 0 to infinity dt by 1 plus root 1 plus x into t whole square. It is in the form of 1 by 1 plus x square. What is the integral? Tan inverse x. So it is tan inverse root 1 plus x into t, but we have to divide by derivative of root 1 plus x into t, that is root 1 plus x. Now write the limits 0 to infinity. If you substitute t is equal to infinity, tan inverse infinity tends to pi by 2. So we will get pi by 2 root 1 plus x. If you substitute t is equal to 0, it will be completely 0. So I dash x is equal to pi by 2 root 1 plus x. Now let us find I of x. I dash x is equal to pi by 2 root 1 plus x. How to find I of x? By integrating on both sides, but this is indefinite integration without limits. What is the integral of 1 by 2 root 1 plus x? It is root 1 plus x. Derivative of root 1 plus x is 1 by 2 root 1 plus x. So integral of 1 by 2 root 1 plus x is root 1 plus x. But since it is indefinite integration, we have to write plus c, constant of integration. How to find c now? We have to substitute some convenient value of x for which I of x is known, then you will be able to calculate c. Let us see I of x. In I of x, for what value of x you will get the value of the definite integral without any problem, without actual integration. You can put x is equal to 0, so that this becomes log 1, 0. Integral 0 is 0 in definite integration. So I will put x is equal to 1 on both sides. I of 1 is equal to, this becomes pi root, not x 1, we have to substitute x is equal to 0. If you substitute x is equal to 0, you will get log 1, which is 0. So take x is equal to 0, then this becomes pi plus c. I of 0 is 0, so pi plus c is equal to 0, c is equal to minus pi. Then what is I of x? Substituting c is equal to minus pi, this becomes pi into root 1 plus x minus 1. So this is our answer. Next question. If g of 1 is equal to 5 and integral 0 to 1 g of t dt is equal to 2 and f of x is defined like this, find f triple dash 1 minus f double dash 1. Take f of x, half integral 0 to x minus t whole square into g of t dt. Now for finding f dash x or f double dash x, you need to differentiate this integral, but in the integrand we have x and t both present. Okay, here limits of t are in terms of x. So how to integrate it? Usually if this is completely in terms of t, how do you integrate? you will substitute t is equal to x upper limit, then multiply by the derivative of upper limit like that. But when x is also present, what to do? First, we will separate x and t. How? Expand x minus t whole square, half into integral 0 to x square minus 2tx plus t square into g of t. Okay. Now multiply by g of t inside this bracket, half into integral 0 to x square g of t minus 2tx g of t plus t square g of t dt. Now we can write this sum as three integrals, sum of three integrals. Now in any integral, if possible, we can take out the terms of x, is it not? Because we are integrating with respect to t, we can take out the terms of x. So what will be the first term? Half into, if you write separate integral, we can take out x square integral 0 to x g of t dt. Second, we can take out 2x, minus 2x into 1 by 2 is x. X integral 0 to x, what is the remaining? t g of t. And third is half into integral 0 to x t square g of t dt. Here we cannot take anything outside because there is no x. Now after expanding like this, you can start differentiating it. F dash x is equal to, how will you differentiate this? It is x square is one function, this different integral is another function of x. So using product rule, you differentiate uv formula, u dash v plus uv dash. U dash means what? Derivative of x square by 2 is x, into v integral 0 to x g of t dt plus uv dash. U is x square by 2, v dash, what is the derivative of this integral? We have to substitute t is equal to upper limit x multiply by derivative of x, which is 1. So you will get g of x. Lower limit is 0. So substituting t is equal to 0 and multiplying by the derivative of 0, it will be 0 only. So I am not writing it. Second term, differentiate this again by uv rule. U dash means 1 integral 0 to x t g of t dt, plus into minus will be minus x into derivative of this integral, replace t by x and multiply by the derivative of x 1. So then you will get x into g of x. X into g of x will be x square g of x. So differentiation of the second term is over. Now coming to third term, it is not a product, directly you can differentiate. It is plus 1 by 2 into, replace t by upper limit x multiply by derivative of x 1. You will get x square g of x. Now observe, x square by 2 g of x plus x square by 2 g of x is x square g of x. Here we have minus x square g of x. So these three will cancel. Now let us differentiate. Once again, f dash x becomes f double dash x. Is equal to, this is a product. So differentiate using uv rule. Derivative of x is 1 integral 0 to x of g of t 1 into integral 0 to x g of t dt plus x into derivative of this integral g of x. X into g of x. Next, this. What is the derivative? Directly replace t by x. You will get minus x g of x, this one. Now, x g of x cancels. Now, what do you want? F triple dash 1 minus f dash 1, f double dash 1. So, differentiate once again. F triple dash x is equal to g of x. Now, f triple dash, 1 minute. F triple dash 1 minus f double dash 1 is equal to, putting x is equal to 1 here, you will get g of 1 minus, substitute x is equal to 1 here, integral 0 to 1 g of t dt. Now, g of 1 is given as 5, integral 0 to 1 g of t dt is 2. So, this is 5 minus how much? 2. Answer is 3. Okay. Next question. Integral 0 to pi by 2 dx by a square sin square x plus b square cos square x whole square. If you remember, we have solved this question without square in the previous classes. Integral 0 to pi by 2 dx by a square sin square x plus b square cos square x. We have solved or not? How did we solve? Multiplying and dividing by secant square x or taking cos square x common from the denominator. You will get numerator as secant square x dx, denominator will be a square into tan square x plus b square. Now, what is the idea behind multiplying by secant square x? We are going to substitute tan x is equal to t. Derivative of tan x is secant square x, no? So, we put tan x is equal to t. Then differentiating on both sides, secant square x dx is equal to dt, and this becomes dt by a square t square plus b square. What are the new limits? If x is 0, t is 0. If x tends to pi by 2, t tends to infinity. What is the integral now? It is in the form of 1 by x square plus a square. Integral 1 by x square plus a square is 1 by a tan inverse x by a. 1 by a means 1 by b tan inverse at by b. Now we have to divide by the derivative of at, that is a. So you will get 1 by ab. Now limits are 0 to infinity. Now substituting the limits, tan inverse infinity tends to pi by 2. Tan inverse 0 is 0. So what are you getting? Pi by 2ab. Why am I solving this question? The given question is whole square. You must be wondering. Now see the magic. How I will get that integral from this integral? What did we prove? Integral 0 to pi by 2 dx by a square sin square x plus b square cos square x is equal to pi by 2ab. This is what we proved. Now, here what are a and b? They are constants and they are independent constants. So, we can call the constants a and b as some parameters independent of x. Okay. Since a and b can take any value, we can assume that they are variable parameters or variable constant. Now, let us differentiate both sides with respect to a. Differentiating with respect to a, what will you get? We can assume that this is a function of a. Integral 0 to pi by 2 remains same. What is the derivative of 1 by t? Minus 1 by t square. So, you will get minus 1 by a square sin square x plus b square cos square x whole square into derivative of a square sin square x plus b square cos square x with respect to a. With respect to a means x and b must be treated as constants. So, what is the derivative of this? 2a sin square x. So, right here 2a sin square x. This is the derivative of LHS with respect to a. What is the derivative of RHS with respect to a? Pi by 2b is constant. Derivative of 1 by a is minus 1 by a square. So, it will be minus pi by 2a square b. Now, take minus 2a to right side, it becomes integral 0 to pi by 2 sin square x dx by a square sin square x plus b square cos square x whole square is equal to what? Minus sign cancels. You will get pi by 4 a cube b. Okay. In the same way, if you differentiate with respect to b, I am going to write this corresponding step without writing this. Similarly, integral 0 to pi by 2 what will you get if you differentiate with respect to b and follow the same steps? In place of sin square x, you will get cos square x, and a becomes b, b becomes a. So, you will get cos square x by, denominator remains same, a square sin square x plus b square cos square x whole square dx is equal to what we will get in the RHS? Pi by 4a into b cube. Pi by 4ab cube. Now, you can easily guess what am I going to do? Adding this and this, denominator is same, sum of the numerators is sin square x plus cos square x 1. I am going to get the asked integral. So, adding 1 and 2. What is the sum of this and this? It is integral 0 to pi by 2 1 by a square sin square x plus b square cos square x whole square into dx. If you add this and this and take LCM, you will get the LCM 4 a cube into b cube, and numerator will be pi into a square plus b square. So that is our answer. Okay, so you might have observed, by using differentiation technique, we can solve the definite integrals very comfortably. But don't try this method in every problem where normal method will be direct. Okay, so sometimes if you are not able to get the method of finding the definite integral, this is one of the ideas. Next question: if f of x is differentiable in the interval 0 to 1 and f of 0 is equal to 0, f of 1 is equal to 1, find the minimum value of integral 0 to 1 f dash x whole square. For finding the minimum value of the integral or maximum value of the integral, we use inequalities of the definite integral. We have discussed many inequalities in the previous classes. One of them is Cauchy's inequality. What is Cauchy's inequality? Cauchy's inequality is, if f of x and g of x are two functions, integral a to b f of x into g of x dx whole square is always less than or equal to integral a to b f of x whole square into integral a to b g of x whole square. We discussed or not? Now I am going to apply this. Now I want integral f dash x whole square. So I will take f dash x in place of fx, and I will take g of x as 1. So it becomes, and limit says 0 to 1. Integral 0 to 1 f dash x into 1 dx whole square is less than or equal to integral 0 to 1 f dash x whole square dx, which is this, into integral 0 to 1 square dx. What is this integral? Integral f dash x is f of x. Then substituting the limits, you will get f of 1 minus f of 0 whole square less than or equal to integral 0 to 1 f dash x whole square into, what is this integral? Integral 0 to 1 dx, it is 1. And what is this? 1 minus 0 whole square, f of 0 is 0, f of 1 is 1. So f of 1 minus f of 0 is 1. 1 square is 1. So now we can write this as integral 0 to 1 f dash x whole square dx is greater than or equal to 1. 1 is less than or equal to this, means this is greater than or equal to 1. Hence its minimum value is 1. Okay. Let us proceed to the next question. We have solved a similar model in the previous class. If you remember, the question is f of x is equal to x plus integral 0 to 1 x square y plus xy square into f of y dy. Then find f of x. The approach for this question is same. First we have to identify the nature of the function. Let us take this. F of x is equal to e power x plus multiplying by f of t inside integral 0 to 1 e power x f of t dt plus integral 0 to 1 t e power minus x into f of t dt. Okay. Since x is independent of t, I can take out e power x. E power x integral 0 to 1 f of t dt plus we can take out e power minus x integral 0 to 1 t f of t dt. Now, if the limits of a differential integral are constants, the total differential integral is a constant, a number. Whatever is the function, after integrating and substituting the limits, because the limits are constants, it is a constant. Similarly, this is also a constant number. Now observe what kind of function is f. E power x into 1 plus some constant, here e power minus x into some other constant. So let us assume that f of x is some constant a into e power x plus another constant b into e power minus x. Let f of x be equal to a e power x plus b e power minus x. Now then what is a? Coefficient of e power x, 1 plus this integral. A is equal to 1 plus integral 0 to 1 f of t dt. We can now take f of t as a e power t plus b e power minus t. Okay. Now we can find this integral 1 plus a into integral of e power t is e power t, and substituting the limits 1 and 0, you will get e minus 1. Is it not? Next, integral of b e power minus t is minus integral of b e power minus t is minus b e power minus t. Substituting the limits, what will get? 1 by e minus 1. I will directly write 1 by e minus 1. Now you can write all the terms in one side. E minus 2 into a minus of or plus e square minus 1 into b by e plus 1 is equal to 0. Okay. You keep this equation like this, equation 1. Now what is b? It is coefficient of e power minus x, which is this integral. B is equal to integral 0 to 1 t into f of t. F of t will be a e power t plus b e power minus t. Now b is equal to a into a is constant. What is the integral of t e power t? Integrating by parts separately, you will get e power t into t minus 1. E power t into t minus 1 between limits 0 and 1 plus b into derivative of t e power minus t, you find and take the limits. Now substituting upper limit and lower limit, you are going to get another equation in a and b. You solve that equation and this equation, you will get the constants a and b in terms of e. Then write the function f of x. So you finish the calculation part so that we can solve more questions. integral 0 to pi theta cube into log sin theta d theta is equal to k integral 0 to pi theta square into log root 2 sin theta. Then find k, that is the question. Let us take LHS. Okay. Observe, theta cube has to become theta square, and here instead of log sin theta you should get log root 2 sin theta. First I will apply the property. The only possible property is first property, you can replace theta by pi minus theta, it remains same. Integral 0 to pi minus theta whole cube into log of sin pi minus theta is sin theta. Now, if this is I, this is also I. Usually whenever you apply this property, you will add the two integrals, no? So, adding this and this, 2I is equal to integral 0 to pi log sin theta is common. So, you will get theta cube plus pi minus theta whole cube into log sin theta d theta. Okay. Now, if you expand pi minus theta whole cube, this theta cube cancels. So, what are the remaining terms? Integral 0 to pi theta cube cancels, you will get minus 3 pi, you will get 3 pi theta square minus 3 pi square theta plus pi cube, plus pi cube into log sin theta. Okay. Now write as sum of three integrals. First integral 3 pi integral 0 to pi theta square into log sin theta d theta. Second, you can write 3 pi square outside minus 3 pi square integral 0 to pi theta into log sin theta next. Third, pi cube into integral 0 to pi log sin theta d theta. Now, in the RHS we have theta square, so don't touch this. You have to combine these two and combine with this, finally get that answer. Okay. So, I am going to come from last. I will find out this, then this. Let us take integral 0 to pi log sin theta d theta. Replacing theta by pi minus theta, we are getting the same function, log sin pi minus theta is log sin theta. Then we can apply a property. What property? You can divide the upper limit by 2, multiply the integral by half, multiply the integral by 2. So, you can write this as 2 integral 0 to pi by 2 log sin theta d theta. This is a standard formula. Integral 0 to pi by 2 log sin x dx or integral 0 to pi by 2 log cos x dx is what? Minus pi by 2 log 2. So 2 into minus pi by 2 log 2. So it is minus pi log 2. ln2 means logarithm to the base e, log 2 to the base e. Now coming to this integral. Integral 0 to pi theta log sin theta. Replacing theta by pi minus theta, this part remains same. If you remember, I have given a formula, integral 0 to a x f of x dx is equal to a by 2 integral 0 to x 0 to a f of x dx. When if f of a minus x is equal to f of x. This is a shortcut. Here replacing theta by pi minus theta, this function remains same. So directly I will apply that. What will I get? Pi by 2 into integral 0 to pi by 2 into integral 0 to pi log sin theta. This is this integral minus pi by 2 log 2. So substituting here, minus pi square by 2 log 2. Okay. Now let us substitute these two in the previous step. 2i is equal to integral 3 pi integral 0 to pi theta square into log sin theta d theta. Next is minus 3 pi square into minus pi square by 2 ln 2 will be plus 3 pi power 4 by 2. Check. This is minus pi square by 2 ln 2. So plus 3 pi square by 2 into ln 2. Next is pi cube into this. Pi cube into this is what? Minus pi power 4 ln 2. You can combine these two. 3 pi integral 0 to pi theta square into log sin theta d theta plus, what is this? It will be plus pi power 4 by 2 ln 2. Now I want to combine this and get theta square into ln root 2 sin theta. We can write this as ln root 2 plus ln sin theta. Multiplying the theta square ln sin theta is already here. So what else you want? Second term should be integral 0 to pi theta square ln root 2. Okay, then you will get the idea. We can write this half ln 2 as ln root 2. Pi power 4 into, can't we write it as ln root 2, half ln 2? but if you want to combine with this, we should be able to write this as a definite integral between limit 0 and pi. Now, integral 0 to pi, and we also want theta square to be common. What is integral 0 to pi theta square? It is theta q by 3, then substituting the limits, you will get pi q by 3. So, I will separate pi cube, divide by 3 and multiply by 3. I will write it as 3 pi into pi q by 3. You can write this pi q by 3 as integral 0 to pi theta square. So, 3 pi integral 0 to pi theta square into ln sin theta d theta. Here take 3 pi, separate 3 pi, remaining can be written as integral 0 to pi q by 3 is integral 0 to pi theta square. Since log root 2 is a constant, we can keep it inside or outside. I will keep it inside. Now, 3 pi is common, integral is common. Combining them, 3 pi integral 0 to pi theta square is common. Theta square into log sin theta plus log root 2 will be log of root 2 sin theta. Okay, now we got it in the form of the RHS. This is 2i. So, I is equal to 3 pi by 2 into this integral. So, the value of k is 3 pi by 2. Okay. Next question. Integral 0 to infinity tan inverse 3x minus tan inverse x by x. In this question, I will assume that in place of 3, I will take some constant a. Integral 0 to infinity tan inverse ax minus tan inverse x by x. A is some constant independent of x. So, a is a parameter. After integrating with respect to x and substituting the limits, final answer will be the value of this different integral will be in terms of a now. So, I will take it as I of a. Now, you must have catched my idea. I am going to find I of a by differentiation technique. Then finally, I will put a is equal to 3. Okay. Here, I dash a is equal to what is the derivative of this integral? Integral 0 to infinity, x is constant. Derivative of tan inverse ax with respect to a is 1 by 1 plus a square x square into derivative of ax with respect to a will be x minus derivative of tan inverse x is 0 whole divided by x. Okay. Now, what happens? X cancels. It is integral 0 to infinity dx by 1 plus ax whole square. What is the integral now? Tan inverse ax by a. Now, substitute limits 0 to infinity. If x tends to infinity, then we get tan inverse infinity pi by 2. If x tends to 0, it is 0. So, it is pi by 2a. I dash a is pi by 2a, then what is I of a? By indefinite integration, we get pi by 2 into log a. But we have to write constant of integration. For finding c, we have to substitute some suitable value of a, for which I of a is known. For what value of a, you will get I of a easily. Putting a is equal to 1, we are getting I of 1 as tan inverse x minus tan inverse x 0, between 0 and pi by 2 integral is 0. So, putting a is equal to 1, this will be 0, log 1 is 0, plus c. What is I of 1? 0. So, we get c is equal to 0. Therefore, I of a is pi by 2 log a. Then put a is equal to 3 and get the answer for this question. I of 3 is equal to pi by 2 into log 3. Next question. F of x is equal to sin x plus integral minus pi by 2 to pi by 2 sin x plus t cos x into f of t. Then find f maximum. The approach is similar to one of the questions we solved today and even in previous class. First, to observe the nature of f of x. F of x is equal to sin x plus sin x into f of t. Now, we can take out sin x and write it as integral 0 to 1, sorry, not 0 to 1, integral minus pi by 2 to pi by 2 f of t dt plus this into this. Again we have cos x, we can take it out, cos x into integral minus pi by 2 to pi by 2 t into f of t dt. Okay. Now, this definite integral is a constant because limits are constant. This is constant, this is also constant. So, what kind of function is f? Sin x plus sin x into some constant plus cos x into some constant. So, f of x is a function of the form a sin x plus b cos x. Let us assume that f of x is a sin x plus b cos x. Now, what is a? A is coefficient of sin x. In f of x, coefficient of sin x is 1 plus this integral, 1 plus integral minus pi by 2 to pi by 2 f of t dt. Since we have assumed f of x like this, f of t will be a sin t plus b cos t dt. Now, calculating, a is equal to 1 plus integral minus pi by 2 to pi by 2 a sin t will be 0 because sin t is odd function. Cos t, directly you can write integral of cos t as sin t and b sin t, substituting the limits, what you get 2b. Okay. B sin t, no, sin t, sin pi by 2, yes, 2b. So we will get a minus 2b is equal to 1. This is one equation. Now similarly, b is equal to coefficient of cos x, that is integral minus pi by 2 to pi by 2 t into f of t. What is f of t? A sin t plus b cos t. This time t cos t is odd function. Replacing t by minus t, we are getting minus sign. So integral of t cos t will be 0 in this interval. Now what is the integral of t sin t? I think you will get a into integral of t sin t is minus t cos t plus sin t. You know how integration by parts? By integrating by parts, first function into integral of the second minus integral derivative of the first function into integral of the second. Okay, integral of this is minus is plus. Okay, now substituting limits, substituting pi by 2 this and minus pi by 2, this will be 0 and this will be 2a. Now solving this and this, you will get a is equal to, substituting b is equal to 2a, a is equal to minus 1 by 3, b will be minus 2 by 3. After getting a and b, how to get f maximum? All of you know the formula that maximum value of a sin x plus b cos x is root a square plus b square. Therefore, f maximum is equal to root a square plus b square. How much you will get? Root 5 by 3. Okay. Next question. If a is greater than 0 and integral 0 to a tan inverse root x is equal to integral 0 to a cot inverse root x, integral part of, find a. Here we know that if x is positive, root x is positive, then tan inverse root x lies between 0 and pi by 2. 0 and pi by 2 means it lies between 0 and 1.57. If it lies between 0 and 1, integral part is 0. If it lies between 1 and 1.57, integral part is 1. So we have to break this integral at 1. At what? At what value? At tan inverse root x is equal to 1, we have to break. If tan inverse root x is equal to 1, then root x is equal to tan 1, x is equal to tan square 1. So let us split it. Integral 0 to tan square 1. In this interval, tan inverse root x lies between 0 and 1. So this integral part will be 0. Plus tan square 1 to the upper limit a. In this interval, integral part will be 1. Now coming to RHS. Cot inverse x also lies between 0 and pi by 2 when x is positive, when root x is positive. But the difference is tan inverse root x is increasing function, cot inverse root x is decreasing function. So though it lies in the same interval, it is decreasing. So it decreases from 1 pi by 2 to 0. Okay. it decreases from 1.57 to 0. From 1.57 to 1, integral part is 1. From 1 to 0, integral part is 0. Here also we have to break this integral at cot inverse root x is equal to 1. If cot inverse root x is 1, what is x? Cot square 1. So let us write this RHS, integral 0 to cot square 1. In this interval, it lies between 1.57 and 1, integral part is 1. Next is cot square 1 to the upper limit a. In this interval, integral is 0, integral part is 0. Now integral of 0 is 0 here and here. What is the integral of this? Integral of 1 is x. Substituting the limits, you will get a minus tan square 1 is equal to, here integral of 1 is x. Substituting the limits, you will get cot square 1 minus 0. So a is equal to tan square 1 plus cot square 1. This is the answer. Okay. Next question. Integral 0 to 1 sin t dt is, sin t by 1 plus t dt is alpha. Then find this integral in terms of alpha. Let us write it here. We have discussed some properties, some shortcuts. If you want to convert this integral into this form, first of all we have to remove this 2 pi from the limits. If I want to subtract 4 pi from the limits, I have to add 4 pi to the variable t. So I will subtract 4 pi from the limits. You will get the new limits as minus 2 to 0. Then here t should be replaced by 4 pi plus t, is it not? If I have to subtract 4 pi from the limits, I have to add 4 pi to t. Denominator is 4 pi plus 2 minus of 4 pi plus t dt. What is this? Sin 2 pi plus t by 2 is sin t by 2. By 4 pi cancels, 2 minus t dt. Now I have to get sin t by 1 plus t. Now I will put t by 2 is equal to some z or x. Put t by 2 is equal to x. I have to also get plus sign here. So I will substitute t by 2 is equal to minus x. Then differentiating on both sides, 1 by 2 dt is equal to minus dx. What will be the new limits now? If t is minus 2, x is 1. If t is 0, x is 0. Numerator, sin minus x is minus sin x by 2 plus 2x into dx is minus 2 dt, dt is minus 2 dx. Now you can interchange the limits and write minus sign. Then this becomes integral 0 to 1 sin x by 1 plus x dx. But you will get minus sign. Check. Here you got minus sign. Here t is equal to minus 2x, so plus 2x. So check the calculation. If this is alpha, this is what? Minus alpha. So final answer is minus alpha. Next question. Here I will give the idea, because only 2 minutes left, so I may not be able to complete the calculation. First, whenever the limits are minus a and plus a, I have told one important point. You should first check function whether it is even or odd. If the function is neither even nor odd, then you have to apply the property a plus b minus x property. Here this is even function, but this is neither even nor odd. Replacing x by minus x, we are not getting same function or minus sign. So it is neither even nor odd, so multiplying by this also it is neither even nor odd. So we have to replace x by a plus b minus x, means minus x. You take this integral as I, replacing x by a plus b minus x minus x. Replacing x by minus x, this remains as it is, x power 4 by 1 minus x power 4. Here you will get cos inverse of minus 2x by 1 plus x square. What is the formula of cos inverse minus x? Pi minus cos inverse x. So it will be pi minus cos inverse of 2x by 1 plus x square. Now adding this and this I and this I, 2i is equal to, this cos inverse term will cancel out. Remaining will be what? X power 4 by 1 minus x power 4. Rest all you complete. Only integrating x power 4 by 1 minus x power 4, you can, I hope you can do it, and by factorizing denominator and writing partial fractions. Okay. So with this we are going to conclude the session for today.